Good morning everyone. I am Ganga Devi from SFR College. Through this tutorial we are going to see what are the functionalities of data link layer in computer networks. So what is a data link layer? So the data link layer is the second layer in OSI model. It is responsible for transmitting the data from one system to another system without any error. So the functionalities of the data link layer are, the first one is the framing. So through this layer it receives the raw bit stream of data from the physical layer, that is the below layer of data link layer, and it breaks that particular data into some frames, and after breaking that frames, it computes some checksum value and affix it with the frame and transmit it through the network. At the destination side, the particular frame is received and at that side it again computes the checksum and compare it with the sender side checksum. Okay, so error control. So after checking that checksum value, it determined that whether the transmitted data is getting any error or not, and also it's the functionality of this layer to correct the error. Okay, so this layer is finding the number of bits that are getting corrupted and also the location of the corrupted bit, and after that it just recorrect the particular error, that is it remove the error and transmit the original data to the user. This is the functionality of this data link layer. Okay, so next functionality is the flow control. So that is the data transmission rate is the main thing that is to be notified. So this layer is responsible for maintaining the speed of the data transmission. So if there is any discrepancy between the data transmission, then we have two issues. One is at the server side, we cannot get the acknowledgement of the data that is sent, and at the receiver side there may be some the data dropping rate, that is the packets may be getting missed due to this delay in the data transmission rate. It should be controlled by the data link layer. Okay, so here through this layer we are going to find three different types of errors. The first error is single bit error, that is on transmitting the data from the sender side to the receiver side, any one bit is getting corrupted, that is the single bit error. If there is more than bit is getting corrupted, then that is called the multiple bit error. And last one is burst error, that is more than one continuous bits if they are getting corrupted, then it is called the burst error. So this is the responsibility of the data link layer to correct to detect and correct all those errors. Okay, let me see the techniques that are used here. The first technique is the parity check technique. So here the frames are getting calculated a parity bit, that is within the frame a single parity bit is getting added, and at the receiver side the parity bit is checked for the error detection. And second option is checksum, that is we are going to calculate a binary addition between the frames that we are going to send, and the value is passed as the checksum value, and at the receiver side the reverse process is going to taken and it check whether there is any error or not. And final one is CRC, cyclic redundancy check. Here binary division is used for the purpose of finding the error. So parity check. What is a parity check? Here this parity check is very much suitable for the single bit error detection. If there is only one bit is getting corrupted, then this method will be used there. So the parity bit is nothing but an extra bit that we are going to add with the original data. So at the sender side what we are going to do is we are going to count the number of ones that are available in the data. If there is the number of ones is even, means if you are going to follow even parity, if the number of ones is even, means then we are passing the parity bit as 0. If the number of ones is odd, means then we are going to make it as a even, that is by passing 1 for the even parity bit. Likewise for the odd parity the vice versa method should be followed. Okay. At the receiver side the receiver should notify what is the parity bit and they have to count the number of ones in the data that is passed. If you are following the even parity, then it should check the number of ones in that particular data should be even. If it's so, then there is no error, otherwise there will be a single bit error will be there. Okay. So this is an example. Now if we are going to transmit the data 1001001 means then on counting the number of ones at the sender side, there is 3 ones are there. So since there are 3 ones and we are going to follow even parity, okay. Since there are 3 ones which is odd, we are going to pass the parity bit as 1. At the receiver side, if there is no any error means then it will get the count at that side. So now it is getting counted as 3 plus 1 parity bit which is equal to 4, which is even parity only. So it conclude that there is no error, okay. So checksum. So the next thing is the checksum technique. Here the data we are going to pass is getting divided into a fixed size frames. Okay, frames or it may be also called as segments. At the sender side, what we are going to do is we are going to add those segments with using ones complement binary arithmetic operation, and we are going to complement the sum. Okay, this is the checksum value we have to pass on to the receiver side. At the receiver side, the incoming segments and the checksum value all are getting added by using ones complement method, and the result and we are going to check the complement result. Okay, if the result is 0 means then there is no error on the transmission way. Okay, if it is not, then there is the error. Okay, so let me see the example. So this is the example. At the sender side, the segment 1 and segment 2 are getting added, and the added value is getting complemented. So which is the bold value is the checksum value. Then at the receiver side, again the 2 segments along with the checksum is getting added, it gives 1, right. So on complementing the value, it is getting 0. If it's so, then there is no error. Okay. So the final one is the CRC technique, cyclic redundancy check technique. So here it involves the binary division of the data we are going to pass. So for dividing the data, what we have to do is we have to consider a predetermined divisor which is normally generated using polynomial method. Okay, so at the sender side, what we are going to do is we are going to divide the given data segment by that particular divisor we are concluding. Okay, after that we have to pass that particular reminder value as the CRC bit to the receiver side. At the receiver side, they have to, that is we are passing the CRC bit also, right. So now they have to divide that CRC affixed value with this divisor. If the reminder is 0 means then there is no error, otherwise there is an error. So let me see the example. So this is the bit stream we are going to transfer 1001101. Okay, here what the polynomial we are going to use is x cube plus 1. So x cube plus 1 means on expanding it, what we get is 1, x square is 0, x is 0. So we are getting the divisor value as 1001. So at the end, what we have to do is we have since we are having 4 bits, we have to add a 3 bit at the end of the transmitted value, and we have to divide it using 1001. Okay, so on dividing it, we are getting a reminder, isn't it? That reminder value is the CRC value we are going to transfer. At the receiver side, what we are going to do is, at the receiver side, that particular CRC bit affixed value is again getting divided by the 1001 value. Okay, here look at this, we are getting a reminder value. If the reminder is 0, then there is no error in the transmission, but we are getting some other value. So we are getting the error here. Okay, so these are the techniques that are used by the data link layer. So on using these techniques, it concludes that the data transmitted by us is not getting any error on the way of transmission. Okay. Thank you for watching. Let me see in the next tutorial.